Okay, this is Geometry Practice for 2.1 and 2.3 quiz. I asked you to do number 1, 2, and 3. Now, while you're finishing those up, I'm going to rewrite a couple of them because I'm going to make sure I show them both of the ways they could have been done. Number 2, I expect it to be done one way. And number 3 might have been done too. So I'm going to do that, and then I'll start seeing how you guys did. Okay, how many of you have finished all three? Okay, I'll wait a little bit longer for the rest of you to try it. I want you to learn something from it if you make a mistake. That's the whole point. How many more have finished? New people. Okay, we're going a little, I know, start it up right away. Now, please look at how you started number 1. How many of you started number 1A? By the way, I started number 1. I was adding 11x. Nobody added 11x first. Thank you. I really want to know. Okay. How many of you subtracted x? I better see more hands go up if you didn't answer to the last question. Okay. So that's why I said I'd show it both ways in case you made a boo-boo, because it doesn't matter. I think the easiest way is this way, because you're going to make sign errors this way. Okay, now, the reason I say that is because if you added 11x, then you would add 33 to both sides. I'm just going to finish this real quick. The fewest number of people said this. That 60 equals 12 times x. Then you would have divided by 12 and gotten 5. Okay, doesn't matter what side x is on. How many of you got 5 and you did it the second way? How many of you got the wrong sign? Or you probably won't want to admit that. Okay, so hold off. This is where we make mistakes. You cannot add 33 to both sides if you did it this way. And that's what I'm seeing people do. That's why I'm bringing it up. Yes, ma'am. That's exactly what I'm doing by getting, but you can't, okay, you have 10x or negative 10x? Okay. Okay, so essentially, did you have a teacher who tried to teach you to move it to the other side? Oh, that stinks. I'm so sorry. It's not that it doesn't work all the time, but it does not work when we get into advanced mathematics. That's why I'm saying that, and I don't mean it in a mean way, okay? Because we're not moving things. That's not what we're doing. We are doing the same thing to both sides to keep it balanced. And so when we get into advanced math, it makes you understand it better if you think of it the way I'm trying to tell you, and I'm not saying you can't do them though. Okay? But when you get into something like you're solving a problem like this, you're not moving anything. You have to square both sides. You have to know that you're doing the same thing to both sides, and that's why it's important. All right, so I apologize if that happened and you got somebody who decided to tell you to move it. But anyway, it's okay. We'll get it figured out. But you did get positive 5, sweetie? That's great. All right, so if you were doing this one, the one thing all I wanted to really get into is do not add 33, because then you'll have a 0 over here. You need to subtract the 27 if you did it this way, and you can still get it right. This is a perfectly fine way to do it, but you would have negative 60, and then you would have had to divide by negative 12, and then you would, and this is where kids make mistakes. They'll forget to bring in a negative sign or something, and then they get the sign wrong. It still should be positive 5 if you did it right. Okay? All right, moving on. I digressed. I went into something I didn't plan on going into, but we can move on. All right, this one we should have definitely added x to both sides. You would have 2x plus 14 is equal to 11. You should have subtracted 14. You would have 2 times x is negative 3, and you divide by 2 and get negative 3 halves, which you could have written negative 1.5. Just make sure you had the sign on it. Okay, number 3. I wrote it both ways, again, because some students probably added 2x and some probably subtracted an x. If you subtracted x, you would have 20 minus 3x equals 8. And then here's where we start making mistakes. If you had added 2x on this instead, you would have 20 equals 8 plus 3x. And now on the first method, you'd have to subtract 20. And here's where the sign errors come in play. Negative 3 times x equals negative 12. You would divide by negative 3 and get positive 4. If you have something other than positive 4, you had a boo-boo in there. If you subtract 8 on this one, here's how you get a positive 4 very quickly, because you're just dividing by 3, and your x just isn't on the left, it's on the right. No big deal. All right, hopefully you found any error. If you got 4, you're all good. If you have a negative 4, you did something wrong. And if you have anything other than that, you are doing something quite wrong. And I need to maybe help you later. All right, now, converse. All that stuff we talked about the other day. If P, then Q. That was your conditional. Then you had the converse, which was if Q, then P. Then we had the inverse, which was not P, then not Q. See? Oh, I wrote a mess. I was trying to write too fast, okay? Not P, then not Q, that's your inverse. And then you had your contrapositive, not Q, then not P. So if you write the converse, if an angle is obtuse, the hypothesis, an angle is obtuse, it measures between 90 and 180 is the conclusion. You want to switch the hypothesis and the conclusion. You didn't have to underline those. I'm just trying to remind you of things we did Friday. So if it measures between 0 and 90 and 180, excuse me. Then an angle is obtuse. Okay. Does anybody need this? Okay. Now I'll try to do a tiny bit of abbreviations in here if we just shorten these up a little bit. I didn't have much I could do on that one. And if you wrote, if an angle measures between 90 and 180, then it is obtuse. That's absolutely fine, as long as the sense is the same as what I wrote. Okay, 5, the inverse. If P, then Q is the regular conditional. If Q, then P is the converse. The inverse is not P, then not Q. So we want to negate the hypothesis and the conclusion. Does someone want me to tell me a way to write this in inverse form? Come on, I have somebody who knows how to do it. They're just going to tell me. All right, I should know. Go, Evan. Okay, perfect. If a triangle is not equilateral, then it is not isosceles. I-S-O-S-C-E-L-E-S. That's how I memorized how to spell it. Just said it with a little bit of rhyme or something. Okay? Triangle is not equilateral, then it is not isosceles. That is the inverse of this statement. If a triangle is equilateral, then it is isosceles. Number 6, write the contrapositive. What? You still need that? Okay, let's stay right on it. On the next one, the contrapositive, if you know that you don't have to write these down every time. I'm just doing that for all of us. If P, then Q, if Q then P, this is the statement, this is the converse. The inverse is not P, then not Q. Be thinking about the next one. And then the contrapositive is not Q, then not P. The contrapositive will negate both of these and flop them. Somebody want to tell me what that would be? Negate, negate, switch. If a quad is a square, then it is a rhombus. I want the contrapositive. It can sound weird. You can just go straight with it. Where are you gonna put a not? In front of that, if it says is, you put a not after is, not a. If you have an is, you put a not after it, and then you flop it. That's all it is. Someone want to tell me what it's going to say then? Oh my word. If it is not a rhombus, okay. If you wanted to write if a quad is not a rhombus, that would sound better, but it's not required. If it is not a rhombus, then a quad is not a square. You can do it. I didn't make it sound pretty. You okay? Well, that excitement at the Johnson's ring thing. All right, identify the hypothesis. Come on, this is the easiest thing you could have to do. But do not include the if or the then, whichever it is. What's the hypothesis of this statement? Okay, say that again, please. Right, two angles form a linear pair. I mean, I don't even care if you just circle it if we're going to be lazy and we don't feel like writing it. Or underline it once. What's the conclusion? Now this one's harder. 8. Two triangles are similar if they are congruent. Rewrite that in if-then form. Okay, I'm going to put someone on the spot. Alyssa, can you tell me if-then form on that? Perfect. If they are congruent. Now, you don't have to do this to do the answer, but I want you to understand it. If they are congruent, then two, and I'll just use it two, triangles are similar. Okay, now, what is the conclusion then? Angel, what's the conclusion? Okay, but in these problems, it's a very specific part of the sentence. So the conclusion will be after the then. Okay, so the conclusion of this statement is the part after the then. And I rewrote this in if-then form. So it's going to be two triangles are similar. That's the conclusion of the statement. The hypothesis was that they are congruent. I said no. Olivia. You would have to flip it because of where they have the if in here. They gave you the if part. So that would be my hypothesis on this one. And the conclusion would be that they're similar. Does that make sense now? And it's only because they said it if they are congruent. So I got to put that first. Okay? What you would have written then would have been the converse. All right? You're welcome. True or false? If it's false, we're going to give a counterexample. This is a little bit odd, right? So one thing I forgot to do is remove the 2 on there. Please just chop off that 2 on the 2x part is greater than 3. Now, I need to remind you that that symbol right there means greater than, if you've forgotten. So there was a typo there. I'd rather just look at it as if x plus 8 is 12, then x is greater than 3. First of all, we have to tell if the hypothesis, what it says. The hypothesis would give me, if I subtracted 8, that x is 4. Okay. Then it says, then x is greater than 3. Is that true? Is x greater than 3? Yes. So this is just a true statement and we're done. It satisfies both the hypothesis and the conclusion, so therefore it's true. That means nothing contradicts each other. All right, so then if we go to number 10, though, which are counterexamples of this? So first I need to meet the hypothesis, must meet the hypothesis, and that would be x is less than 5 if you divided by 3. Okay, now, what ones in there? We want to find counterexamples. This says that x is less than 5. We want to find numbers that are less than 5 in this list down here, which would be A, B, and C. Now, to determine which one are counterexamples, though, they also will not meet this hypothesis, the conclusion, which says x is bigger than 2. What numbers did I point made little? This is not included at all because it's not even equal to 5. So I need something down here that's not bigger than 2. So 1's a counterexample and -3. So there's actually 2 answers that were counterexamples in that problem. Very different. What I want you to understand is a counterexample must meet being less than 5, the hypothesis, and it must not meet the conclusion, and then it's a counterexample. All right, true or false? Give a counterexample of false. If a triangle has a 40-degree angle and a 60-degree angle, then it has an 80-degree angle. I mentioned to you the other day that the 3 angles of a triangle add to, the 3 angles, all 3, add to 180. Okay, now, these 2 are 40 and 60, so that's so far 100. And then it says the third one is 80, so this is all good because they add up to 180. So this one would be true. Okay, now 11, that was 11. 12 says, give a counterexample of false. If a triangle has a 60-degree angle and a 25-degree angle, well, those only add up to 85. Then it's an acute triangle. All angles are less than 90. Well, how do we know if this is true or false? What we'd have to do is check what would the third angle have to be. So if that's 85, it'd have to be what? How would I get it? Or 180 and take away 85, and you were right. You got 95, right? Okay, now, if it has to be 95, is that less than 90? No. So the counterexample is this. Well, first of all, this is false, because the third angle must be 95, which is obtuse, not acute. Okay, now for a triangle to be an acute triangle, all 3 angles must be under 90. Okay, everybody good? Or we need to hold on? Okay, find the distance. All right, I need everyone to have a calculator open, turned on. This is something that we are weak on, and I want to see this quiz score go up. We will be re-quizzing distance and midpoint on Wednesday. You need to know how to do this. I have Preston from my other class. He's going to make a big poster. I'm going to put up a big distance formula poster over there tomorrow if he brings it. I have it written on the board there. I have a sign up there. If you have BS directed studies, how many of you had Geo directed studies? I know it's got to be quite a few. You got another teacher telling you to go x1 minus x2 maybe? Instead of x2 minus x1? I've heard that from some students. It doesn't matter. You got to subtract the x's. But some of you are subtracting the two numbers in the parentheses. Those are not both x's. What are they? One's an x and one's a y. Okay, so little reminder. The x's are the first numbers. You want to subtract them. The y's are the second numbers. You want to subtract them. You might not like it when you get negatives. Here's what we're going to do. The formula says x2 minus x1 quantity squared plus y2 minus y1 quantity squared, and then take the square root. I want you to do this part first. Do not put in the square root. Do this part first. We're messing this up, and some of you got it down. I mean, please just bear with me if you are doing just fine with this. But if you're going to put in your x's, you will need, I'm going to follow the formula, but I'm going to tell you that even if you do the, don't do x2 minus x1, if you do it backwards, it's okay. Because you're going to square it. So it won't matter. Does everybody have their calculator? You could practice, please. You got to find out what you're going to get. I want to help you if you're typing it wrong. I want to help you figure out what you're doing wrong. And then we will do the midpoint after we do a couple of distance ones. If you have your teacher, another teacher telling you to subtract them the other way, it's okay. But you're going to get a lot of negatives on this one. All right, here's how you want to type it on the calculator. Parenthesis, 3 minus, was it -2? Close the parenthesis, hit the squared button. Plus, parenthesis, 11 minus 6. Close it, square it. This is what you should type in the very beginning, and then hit enter. If you are getting 50, you are typing it well. If you're not getting 50, you are doing something wrong. Now, after you get the 50, that's the part under the radical. Now you're going to type the square root of 50. Okay, if I need to help somebody, I would be happy to come over and help you figure out what you're doing that's not working for you. Now I got 7.07. So the distance is approximately 7.07 units. And if you went to the 10th, that would be 7.1. Okay, please go to the next one and try to do it alone. Go. Do number 14. Okay, so x1 is 7, x2 is -2, y1 is 1, and y2 is -4. So you should have started off. I don't know that you did it. I don't like how that came out. That you did. I don't care if you did 7 minus -2 or -2 minus 7. It's okay. -4 minus 1. and I'll explain. And it's okay if you did 7 minus negative 2 squared plus 1 minus negative 4 squared. Why is this okay? Is because that's negative 9 squared plus negative 5 squared. And this is 9 squared plus 5 squared. One of them looks easier than the other. The one that we're messing up is if we get the negative somewhere, if we don't put parentheses in, okay? So it should be the square root of 106. Did you get 106 at least? If you're not, I got to help you somehow. The square root of 106 should come out of either way you did it. And then when you get a square root of 106, you get 10.295. And if I asked you for the nearest tenths or hundredths, you'd round that up. And then you'd have to round that up, so it'd be 10.30. Even if you said for tenths, it'd be 10.3. Okay, gonna move on. Let's go back to 13, please, and now do midpoint. Midpoint, you add x's. I know it didn't ask for that, but we need to practice this. Add y's and divide by 2. Now I'll tell you what's going wrong for people on this. They'll add the x's, negative 2 plus 3 divided by 2, and they'll do 6 plus 11 divided by 2. And I see all these papers where kids actually write down the work, and then they get this wrong because they typed it all in their calculator at once and they did this. They go, negative 2 plus 3 divided by 2. And then they get this is the wrong answer. And I explained that to you when I taught it. What did I explain to you you must do as opposed to what I just typed? Okay. Yes, put parentheses around the negative 2 and the 3, or just type negative 2 plus 3, hit enter, and then hit divided by 2 and get the right answer. All right, which is 0.5, positive 0.5. And then 6 plus 11 is 17, divide that by 2, you should have 0.5, 8.5. Okay, do the midpoint on number 14 right now, please. So in the midpoint, you add and divide by 2. The distance formula, you subtract and square. Very, very different. Okay, you should have decimals on the answer for this one too. What's the x part? 2.5, and the y part? Negative. Careful. Negative 3/2, negative 1.5. Okay, or negative 3/2. I don't care if you leave a fraction. Okay, I would like someone to describe for me what I should draw. I'm going to draw a figure with angles 4 and 5 being acute, and they're vertical. I need to make some vertical angles. What should I do to make some vertical angles, please? Olivia? All right, do you want me to make an X going like that or like that big one? Doesn't matter? It doesn't matter. So I'll do, you can have this or this. Okay, now, show an angle bisector of one of the obtuse angles in your figure. I want to find, let's find 4 and 5 first. Where are the acute vertical angles? Where are they in my picture? I should put some arrows on here, I guess. So Olivia told me to make an X because that gave me 2 pairs of verticals. Where are the smaller ones? On this picture, it's on the left and the right. And on this one, it's, all right, perfect. That's what I need you to know. Okay, now I'm going to label those 4 and 5, and then I'm going to do the next part. You don't have to have both these pictures. You just have to have one of them, okay? Now, it said, the second part says, show an angle bisector of one of two angles in your figure. What's an angle bisector do? Brianna, you're really quiet today. What does that mean? Okay, so that's obtuse and that one's obtuse. I want to cut one of. I want to angle bisector it. What does that mean? I should do to my picture? Draw a line where? From here, down or up? It doesn't matter, right? Okay, so if I go down, now what do I have to show to know what it meant? I did, because I didn't do it perfectly. I don't think. This one is equal to this one. Look, these are equal too, guys, the verticals. Now, if you were doing this picture over here, you just need to make a ray coming out of there and show that these angles are equal. Now, we could have done it with a protractor and made everything all perfect, but that's okay, as long as you show marks. All right, so angle bisector cuts an angle into two congruent angles. All right, somebody tell me how to draw a pair of non-adjacent supplementary angles. Supplementary means add to, oh, oopsie, I almost wrote 90. 180 is correct. Non-adjacent, not next to, right? All right. Someone want to pick me out something to draw? I gotta get you on your toes. Come on, Nathan's. Give me two non-adjacent supplementaries. Tell me what you want me to draw. Uh-huh. Okay, that is one way to do it. He said draw two right angles. That's a very nice, simple way to get it done. You got one, both of them are 90. You can just use the box, would be fine too. But isn't there a ton of combinations? So maybe you want to do something different. You go and draw something like that, and you just pick some numbers. So what's another example? These are just examples. How about 120 and the other one would have to be 60, you know. All right, so there's a whole bunch of answers. Everybody in the room could have a different answer for me if I ask a question like that. I have to look at what they have. You could do 110 and 70. You could do 100 and 80. You could do all kinds of stuff. It's have to add and not be connected. All right, 17, I want to draw a pair of adjacent complementary. Takasha. Adjacent and complementary. Come on. You're not going anywhere yet. What does that mean? What do they do if they're complementary? Yeah, they add to. There's got to be two of them, though. It's not just 90 degrees. We can start with a 90. What will I need to do with it? They're adjacent also. Kylie, you want to help me? Or help Takasha? Yes, you do. Well, that's the whole point, Robert. I don't care if you're wrong. I want you to help me. That, like that? Okay, that makes a 90. It could be an angle bisector. If it's an angle bisector, then how big would each of them be? Uh-huh. That's perfect. Nothing wrong with that. That's fine. Okay, so have some confidence. If you know they add to 90, but could we have done other numbers? All right, so now to question, I'm going to make you give me another pair just so you can tell me something else. Come on, sweetie. Give me some more that add up to 90. That's all. Sure. All right, so you make one be 40 and the other would be? Yes, that's fine. That's a perfect picture. That does the job. They are adjacent, meaning they're connected. They share a common ray, and they are complementary, add up to 90. That's all you need. Okay, I think some of you are thinking some of this is harder than it is. I really do. All right. Given right angle ABC, I want to state a conjecture. A conjecture, you got to know what I'm asking for. All I want you to do is say something besides that angle ABC is a right angle in words. What do you know if it's a right angle? Okay, the measure of the angle ABC is 90. That's it. That's the conjecture. All right, you just have to say angle ABC is 90 degrees. And I use that M for measure, angle symbol, and the letters. I did not, your 19 is not that. Your 19 is this. Given line AB, okay, I need a diagram. We're hanging in there. We're going to get this all finished up. No one's getting up. We're doing it. Okay, so can you start me off with something? Abby. Well, I need a line AB and a line CD. Just tell me even how to start the drawing would be great. That intersect. What does intersect mean? Okay, they cross. So I want two lines that. Okay. I don't care how pretty it is. All right, can you tell me how I might label that, hon? Okay, so you want me to put an A here? And where would I put the B? Over here? Okay, that sounds good. And then maybe do the, it doesn't matter if it's a C or the D either. And then D over here? Okay, and then it says that they intersect at the point X. Right here? Okay, put an X. Thank you. Perfect picture. Now, there are tons of things we could say about this. Lots and lots of different things. The hard part about geometry is understanding it's not like algebra where you solve an equation, you get one answer. Okay? There's lots of stuff we can say. All right, I know you, Chloe. It flips, and what would you like to tell me? I should have said your last name, sorry. Okay, so you said the measure angle AXD is, what do you want to tell me? Okay, angle AXD is obtuse. Okay. Can somebody tell me something else about it? Isn't it vertical to another angle? What is it vertical to? And Priscilla, okay, angle A CXB. All right. They're both obtuse and they're congruent. Okay, they're also congruent. So I just said three things. How about somebody give me something about this angle and this angle? Those two. Okay. Ken? Okay, good. So you could have said the measure of angle equal 180. All right. They don't equal 180. I guess they're supplementary. SUPP. Okay. You could say the measure of them add up to 180. You could say that they're adjacent. Okay. You can say they're a linear pair. Yes. Okay. Did you get the idea? There's a lot of things you can say. You just have to be able to come up with something, right? And the last one I'm not doing right now. All right, do your 2.1 and 2.3 assignments. I can tell a lot of you have not tried them. You've got to do it. Practice.